Good afternoon, ladies and gentlemen. Let me present our paper. It is about modified genetic algorithm for employee workship scheduling optimization. Problem of scheduling, automation, and optimization is one of complex domain problem. It is become complex because we need to pay attention to some constraints together in the same time. Genetic algorithm become a method to solve the problem. These algorithms have been proved to optimize scheduling well. We use the case in Salabali to illustrate that the genetic algorithm is able to solve the optimization of employee workship scheduling well. How it can be done? Salabali have 4 work shifts in a day. It is morning shift, afternoon, evening, and night shift. In 7 days, it becomes 28 shifts. In this table, we saw 28 slots in time slot representation. Each slot will represent a gene in chromosome representation. In this picture, you will see the chromosome representation. K01 code is represent employee with ID K01. So, in this picture, each shift we will have at least 4 employees. For example, gene 1, we have K01 employee, K07 employee, K03 employee, and K02 employee. To avoid hard constraint penalty about equal workday for an employee, we will use chromosome correction. Each employee must be scheduled for 6 times in a week. It means each employee must fill its slot. If there is employee's ID that appear less or more than 6 times, then replacement algorithm will be applied. The replacement algorithm first counting the workdays for each employee. If the number less than 6, then the employee is added to the chromosome. If it is more than 6, then it is reduced to 6. The replacement positions are carried out randomly. This equation is for fitness function. In this case, we have 3 hard constraints and 2 soft constraints. The maximum fitness value for alternative solution is 1. Fitness value 1 means there is no constraint that violate the schedule. This is the result of our experiment. Optimum genetic algorithm variable is shown by the table. The population size, the optimum value is 15. The crossover probability, optimum value is 0.6, and the mutation probability is 0.3. In the first table, we present the change of number of employee and the change of population size. For the first table, we can take the insight that the change of number of employee and the change of population size for this computation still have fitness value 1. So it means that it still have optimum schedule. The second table, we have changed the number of employee, but we make fix the population size. It still can make the schedule optimum. This computation just need more time to make the algorithm done. So this is our conclusion for this experiment. On real case of the Sala Bali Hotel, scheduling 6 front office employee and 15 back office employee, the mutation probability value 0.3 and the crossover probability is 0.6. And this optimum value means that the schedule is formed without any clash of all predefined constraints. The second conclusion, chromosome modification and genes replacement make the schedule still optimum even we change the number of employees without change the number of population size. This is contrast with the common logic that when we extend the chromosome size, we need to increase the population size to provide sufficient variation of the solution in the initial population. Future work. This study is limitation in applying genetic algorithm to real-world case. For further research, it can be examined how the genetic algorithm is designed to solve worksheet scheduling cases that can be applied in general to all cases of scheduling. Thank you.